All right, so in this video, we are going to prove the following. So, what this is saying is it is saying that we are taking the curl of a scalar field times a vector field. Overall, it's the curl of a vector field. And the result of this, it turns out, is it is equivalent to the cross product of the gradient of u with vector v plus u times the curl of vector v. And so we can prove this. So let's start out by rewriting the left side of the equation. Now, since we're taking the curl of something, we are going to act as if we're computing the curl of it. And in the final row, that'll consist of the x, y, z components of our vector field, uv. So in that case, it would be uvx, uvy, and uvz. And so now from here, we're basically computing the curl of this thing. And so to compute the curl, it's just like a cross product, right? For the I component, it's going to be this on this minus this on this. For the j component, we are going to be doing plus this on this minus this on this. And for the k component, it is going to be this on this minus this on this. And so that's really what we're doing. So now what we have to do is we have to take the derivative of each of these things. And so really, for the derivative of each of these things, it's going to involve the product rule. Because u and the components of v aren't necessarily constant, right? They could vary with respect to x, y, and z. So really, we're going to have to use the product rule for each of these. So this would be a sample of using the product rule for the first one, right? For the second one, it would look like this, right? Basically the same sort of idea. The only difference is we have minus signs because the minus sign distributes itself through the product rule. And so now we are just going to do the exact same thing for the j component and the k component. So this is what we have now, after using the product rule for every single one of them. So notice that in each of these 6 terms, they all contain u in it. And what we want to do is we want to group up each of the terms that contain u in it. And we can do so by swapping the middle terms for each component. So we will do that now. And so now we have swapped the middle terms. And so as we can see, the terms that contain u in it are now all next to each other. So now what I am going to do is I'm going to factor out u for each of these pairs of terms for each of the components. So I'll factor out u here, I'll factor out u here, and I'll factor out u here. So now I have factored out u from each of these. So at this point, this entire thing is just a single vector, but we want to convert it into a sum of 2 vectors. Well, we can do that, right? First thing I'm going to do is I'm going to show you that there are parentheses that I can place around each of those pairs of terms. And so we can now think of this as the sum of 2 vectors, right? One vector has these 3 components, and the other vector has these 3 components. And when those 2 vectors were added together, we resulted in this vector. So we're now going to break this singular vector up into a sum of 2 vectors. Again, our first vector will contain these 3 components. So this is our first vector consisting of these components. But then our second vector, we will contain these components. But notice each of these components is multiplied by u, so I am just going to factor out u from the second vector. And so this is what we would get for the second vector. And so this next step is up to you. You need to be able to verify and convince to yourself that this first vector is determined by the gradient of u crossed with vector v, right? So in other words, this first vector is actually the result of a cross product. And you also need to be able to convince yourself that the thing that we have inside this brackets is the curl of vector v. And so I'll leave that as an exercise for the audience, but you need to be able to convince yourself that those are true. Otherwise, if you just want to assume it's true, well, then yes, this first vector does in fact represent the gradient of u crossed with v. And the second vector, well, we have u factored out. That's exactly what's going on here. But everything inside this brackets is really just the curl of vector v. And so now we have proven that these two things are equivalent. And so that's really the whole idea. And so this is basically it for this video. Hopefully there aren't any mistakes with the subscripts up here. That was good, right? That was good. Hopefully there aren't any mistakes, but that would be true. And so this is basically it.